G'day and thanks for tuning into the official Mechanic.com.au podcast, Australia's #1 podcast for developing successful careers and highly profitable workshops in the automotive service and repair industry. In each episode, we interview industry experts from all different areas of our trade. And the best part is, you get to ask the questions. To find out who we're interviewing next, head over to Mechanic.com.au, and if you aren't already a member, make sure you create a free account. But please remember that Mechanic.com.au is for the automotive trade only and is not available to the general public. We hope you enjoy this episode of the podcast.
But in this week's Mechanic.com.au podcast, we're lucky enough to be joined by Andrew French, who's the Product Engineering Manager at Bendix, and Steve Gavin, who's the Chief Engineer over at Disc Brakes Australia. Andrew, let's kick it off. Do you mind telling me a bit about your background and what you do over at Bendix Brakes?
Thanks, Ryan. Yep, I look after all of the product and process development here at Bendix. So we have a site in Australia, of course, where we make the whole range of Bendix pads. We also have a site overseas in Thailand. So we look after everything there, everything from go to woe, so to speak. Been working for Bendix since 2000. Started out in the testing area and then worked my way through to the product engineering manager. In between times, lived in Malaysia, and prior to working at Bendix, I worked for the Department of Defence at one of the proving grounds. So playing with cars a lot of the time.
Nice. And what about yourself, Steve?
I've been working in engineering for over 30 years now, mainly design and manufacturing, various industries in Australia. I originally joined DBA in 1997, had a nearly 10-year stint there, developing new products and working on materials and structural design of disc rotors. And I had a bit of a spell in workshop equipment and mining, and then I came back last year and back as into R&D again, developing new products and dealing with a few challenges that have come up with new vehicles and new applications.
No doubt, that's engineer life for you, though, isn't it? So as you both know, we've thrown it open to the Mechanic.com.au community to ask a few questions prior to this podcast. We've been pretty much inundated with questions, so we're going to do a bit of a rapid fire. We've got quite a bit to get through. So most of these questions relate both to the pad and rotor side, to both Bendix and DBA. So I'll hit you with the first question and we'll charge through them. So the first question we've got here is from Jackson. Jackson asks, what are the advantages and disadvantages of slotted and drilled or just slotted rotors on a 4x4? His local brake shop wouldn't sell him slotted rotors for the reason they fill with mud and ruin the pads. What are your thoughts on that one, Steve?
DBA's had success with drilled and slotted rotors on four-wheel drives in the Middle East. There's an advantage there with clearing free-flowing sand from the brake assembly. Normally, we wouldn't recommend drilled rotors for four-wheel drive applications other than this due to the high stresses generated by heavy vehicles. Drilled rotors are more suited to passenger cars with lighter axle weights, where they're proven to shorten stopping distances in many applications. The most common brake upgrade for 4x4s is slotted rotors with performance brake pads for heavy-duty applications, where the mu or the friction coefficient requirement is higher than OE. Four-wheel drive applications such as towing or heavily modified 4x4s with high GVMs is that market. Not all slotted rotors are the same. The slots in DBA rotors are designed to effectively release dirt and debris. The slots are effective in degassing at higher temperatures when the pad organic materials burn out and removing the dust from the friction surface, which maintains a consistent brake torque. You need to consider your application carefully when selecting a disc rotor. If you're bush bashing or hitting a lot of mud and water, I would agree with your local brake shop and select a good quality plain face rotor. If you're towing or heavy laden vehicle, then slotted rotors will perform better, but you may need to clean out any accumulated mud during your trip as regular undercar maintenance.
Sure. Sounds like you pretty much covered it there, Steve. Is there anything you'd add to that one, Andrew?
Well, of course. Well, being from Bendix, the brake pad you'd choose would be the heavy duty for that application. Four-wheel drive is for regular replacement, and then heavier applications, the heavy-duty range.
Sure. Now, all right, we'll roll on to the next question. This one's from Daniel. He's had a bit of a curly scenario. He's fitted new disc rotors, new GCT pads. He's ensured the caliper is free and the piston moves freely. All surfaces cleaned and greased with high temp grease in all the right spots. He's sent it out, and 2 months later it comes back squealing. What would be the best strategy to tackle that one? Because he's tried to cover all his bases. What would be the best way to tackle that one? I'll start with you on this one, Andrew.
Yeah, sure. Certainly, well, as we all know, brake noise is one of those black boxes, so to speak, but there are many things to check. If it's gone out okay and you've done everything okay at the start of the job, then I'd really be looking at the hardware and trying to isolate, where the noise is coming from on the vehicle. Is it just one wheel or is it both wheels? Because sometimes some of the frequencies are very difficult to discern between front and rear. That's probably some pre-work to do. And then, of course, when you get into the hardware of the brake and you isolate what wheel or axle it is, have a look at the rotor surface. Does it look even? Has it been out in the elements and got any rust on the surface of the rotor? Is there grooving on the rotor? There could be some contamination that's got in there during service, or depends on the conditions it was used in. Following on from that, pad contamination. Has it been exposed to grit and that's got in there and got into the contact area and caused some scoring on the disc, and that's what's caused the noise.
Right.
Additionally, the pad surface, look at has it been exposed to elevated temperatures for a long period? So we all seen those ones that have come back and they look like they've been on a racetrack, but that's not always the case. It could have some ashing around the perimeter of the friction material, crumbling, and then in effect from overheating, glazing, or cracking in the pad as well. Additionally, that would also accompany a high wear rate. From a hardware point of view, things can change in a short amount of time, especially if you've got a binding caliper guide pin, abutment clips if they're damaged. Obviously, if it was 2 months old, you wouldn't think that would happen, but you never know. Mainly around binding and making sure all of the assemblies are free to move. And it's the brake dragging. So as soon as you put the vehicle on the hoist, turn the wheels, is there anything that's binding or stopping the wheel from turning freely? And then last but not least, some pads use grease in between a shim. So mostly on Asian vehicles that you see this, but not a lot of people put that back in there, and the Bendix brake lube that we do provide is also suitable to do that. So put that under the shim itself, and that will help damp the pad further. So one of those phenomena that you can talk about all day, but they're the short and concise answers that I'd give in this particular situation.
Yeah, absolutely. That's a pretty systematic approach to take to it. Steve, is there anything specific to the rotors that you'd throw in there on top of Andrew's little list there?
Yeah, for sure. As we all know, everyone's got a disc rotor these days. Low quality disc rotors can amplify these noise issues. The noise dampening properties of a disc rotor directly relate to the material chemistry and the mechanical specification. Disc rotors with a low carbon content or the incorrect mechanical properties such as tensile strength and hardness can actually increase the risk of these noises occurring.
Okay, so picking a quality rotor and pads, of course, is obviously best to avoid having those comebacks and trying to nut out these issues in the first place.
For sure.
All right, let's charge on to the next one. This one's from Brad. I might direct this one to Andrew in the first instance as well. Can you explain the difference between adhesive friction and abrasive friction? Which component is the primary wear component with each? Which of your pad types use each principle? And what pad types are suited to what driving types? I hope you can remember all that. It's a bit of a mouthful, but...
Well, hopefully we'll be able to answer all of those for you, Ryan.
Let's roll.
Let's start with adhesive friction. So adhesive or cohesive friction is where a third layer or transfer layer of pad materials is laid down onto the rotor or the disc. So typically, if you look out in the car park at, Commodore, we did the OE on that. You'd look at it, you see a honey colour film on the disc as opposed to a shiny disc. That's the transfer layer that I'm talking about. And that film there provides protection to the rotor and keeps the friction consistent in most driving conditions. And it also protects the rotor against wear. Steve probably doesn't want to hear that. It's protected against wear, and it also then, from a wear point of view, it reduces the dust from the rotor component, but the pad, again, is the primary wear component. And the pad is what's transferring between the pad and that transfer film is where the wear is occurring, not so much on the rotor. You will need to replace the rotor eventually, but typically these type of materials, the rotors, from a life point of view, if they didn't form DTV or anything like that, would be in excess of 100,000 kilometres. Typically, NAO or ceramic materials are designed this way. So our Bendix DCT range consists of the ceramic material. So this is the type of materials we use for general purpose or general driving, and also in the four-wheel drive segment. So this is where these materials, again, they're suitable for everyday use. People are very sensitive these days to low dust, low noise and consistent friction. That's what these materials provide. So that's what we'd be, from an adhesive friction point of view, that's it in a nutshell. It's probably our core focus from a business point of view, and around the world these days, people tend to like the characteristics of these materials as opposed to, let's say, European style material where you have a very aggressive friction material. And that one's a good lead into abrasive friction. So again, look out in the car park at your favourite European vehicle. You'll see that the wheels are quite black and dusty, and that's because the friction material on those type of vehicles is an abrasive type material, and the pad abrades the disc while providing little transfer film. So it's actually the pad and the disc wearing at the same time. The rotor appearance is shiny, and it forms a larger part of the wear component compared to adhesive friction. So again, the pad is still the primary wear component, but commonly we see a lot of steel in these type of materials. So typical example of those, I talk about the European cars, also some of the heavy American vehicles like the big F-150 trucks. To a lesser extent, they still use a metallic-based material. So rotor life is much less than the adhesive type material, and dust is somewhat higher than an adhesive type material. So Bendix use these type of materials in the heavy duty and performance segments, such as Ultimate and SRT. So when it comes down to pad selection, it really is horses for courses. What are the people looking for, or your customer? If you're fitting up a vehicle, it's really understanding their needs and fitting the right material combination that suits their driving style and requirements.
Well, I think you pretty much knocked that on the head, though, so we might just skip through to the next question we've got here. So this one comes from John. I know brake drums can have some discolouring and scoring and webbing depending on the manufacturer, but how much is too much, and when is this line drawn? I'll throw this one to you, Steve.
No worries. All of these observations are signs of stress in the brake drum. The iron used in brake drums will go through a colour transition with increasing temperature. Normal street applications, brakes rarely exceed 300 degrees Celsius, which may result in a very light tan straw colour. If you're seeing blue colouring or heavy scoring, you may have an adjustment issue or unintentional application, people driving with the handbrake on. Scoring greater than 0.2 of a millimetre, it's enough to catch your fingernail on, is not ideal. Although it may not greatly affect brake torque, it's likely to increase the risk of noise coming from the drums. Due to low wear tolerances and potential performance issues, Bendix recommends replacing drums if there are any signs of excessive heat stress, cracking or scoring. Poor drum condition can lead to noise issues, as we mentioned.
Yeah, absolutely. So, Andrew, do you have anything to add on to that one?
No, I concur with Steve's comments, but again, it comes back to that quality brake job. Looking at drums these days, really they're not as expensive as they used to be, and probably the recommendation is not really to machine them so much due to their tolerances.
Yeah, absolutely. The next question we've got is from Willie. Now, Willie says, why do GCT pads react with slotted rotors causing shudder, and what pad that's not dusty is good with DBA slotted rotors? Now, on this comment, a lot of other technicians jumped in the group saying, I've never had this problem. So in this case with Willie, what approach would you take? And I'll throw this one to you, Steve.
Yeah, this is probably one of the most common sort of technical issues we deal with from week to week. GCT pads are a general purpose friction material for everyday driving, and DBA slotted rotors are a performance product for aggressive application. Neither product performs poorly in their intended application. From a disc rotor perspective, it's possible the interruptions from the slots at higher temperatures enable an irregular transfer layer thickness to occur with the incorrect pad and rotor combination. The irregular transfer layer thickness is one of the most common causes of brake shudder with steering wheel vibration. The simple solution is to use a performance pad on slotted rotors or a plain face rotor with general purpose pads. The other factors such as wheel bearing wear and hub cleaning fitting issues causing disc run out are less frequent now, but still require some consideration, particularly on sensitive vehicles. Driving style, axle weight may be the reason for differences in the feedback from your other technicians. Most good quality semi-metallic pads perform well with DBA slotted rotors. That's the T2 and the T3 series. T3 is the heavy duty ends. When we talk about dust, dust is the product of wear and good friction. The real dust issue is how much adheres to the wheel and how much falls on the road. We find the dust from good quality semi-metallic pads is less likely to stick to the wheels in performance applications.
Okay, so a lot of that is to do with the mismatch, and again, it all ties back. We talked about the sound issues, the dust issues. A lot of it seems to tie back to really just selecting the right pad and right rotor for the application, it would seem. All right, we'll push on to the next one. I'll throw this one to you, Andrew. This one's from Simon. Now, Simon says, we see a lot of commuter taxis. I'm afraid I don't have the particular vehicle, but I'm thinking of the Toyota Hiace Transporter type setup. Simon says that no pads or rotors appear to last up to 20,000 kilometres. Do you have a suggestion of a combination to try for that particular application?
Sure. Well, it's a common issue worldwide, and naturally brake wear it's a challenge for us because it's relative to really the application and how it's being used in the field. So taxis and courier vans are braking more frequently than the average privately owned vehicle. From a disc and rotor perspective, you're looking for high material hardness to reduce wear. Commuter taxis generally run at higher than average pad temperatures, hence the lower pad and rotor life due to the duty cycle. So expecting sort of normal passenger car life is not really practical. So if you add into that some vehicles' brakes are designed for commercial and passenger applications, and that some don't really last at the high end of the spectrum. And particularly around the Hiace is an interesting one. It's a very popular vehicle. We're currently doing some work on those, and so far to date, comparing to OE, so we're using some guys in the local area here with the commuter buses, and we've baselined the OE material, and so far we've got about 25,000 Ks only out of the OE, and that's only in this area here. This is in the Ballarat region, so I wouldn't call it extremely high duty, but they are taxi drivers. And that's returning about 25,000 Ks, and we've got our heavy duty material is the one that we would recommend on that vehicle. From two aspects. One of them is certainly pad life. It'll be very close to the OE. I'll certainly say within plus or minus 5%. And it's also kinder on the rotors than some other materials that are out there. And it does its best work. The reason for recommending heavy duty it does its best work when it's hot. So heavy duty material being a metallic, it likes a little bit of heat, so it will perform at those higher temperatures compared to the ceramic type material.
Absolutely. Oh, well, that sort of hits the nail on the head on that one. It's always a challenging one, and you know you've got to keep on the head with innovation and testing and R&D and what have you. So I guess that's just a perpetual challenge for you guys. Yeah, obviously it's what you should be doing today. But I appreciate you taking the time out of your day to have a chat. The last, I've just got this one's more of a request than a question. This one's from Lauren, and it's directed at Bendix. Can you please bend the small metal tabs on the brake pad shims so they don't fall off as soon as I unwrap them? I think we had about 25 or 30 guys liked that comment, so I'll just throw that in there as an ask from us mechanics on the workshop floor.
Yep, the feedback is that we're aware of that issue on those parts, and we're working through it with our supplier for those shims. There are a few, let's call it tolerances, variation in tolerances that are leading to that, so we're working on those as a case-by-case basis.
Oh, fantastic. Oh, well, hopefully in the fullness of time we might start seeing that one sorted out. So as far as the
important part, Ryan, sorry, before you go on, is to really use, it's important to Bendix and to all of us, I guess, is to use our call centre and get that feedback. Whether it's through the sales field or whether it's through our call centre, really appreciate, good feedback's also welcome, because most of it, when you get a phone call's not always, but keep those communication lines open with our call centre.
Yeah, absolutely. And I mean, even for the guys listening to that, if you happen to drop any feedback in the Mechanic.com.au Facebook group for either Bendix or GBA, we'll certainly pass that information on. Now, the last question we've got is from Chris. Chris says, why is it that heavy-duty pads appear to wear quicker than general purpose? This appears to be on his personal vehicle. He tows a trailer, weighs in at 4.5 tonnes gross mass, replaces his rotors every set of pads that he changes because it's cheaper than using his lathe apparently. Yet the heavy-duty pads gives him 5,000 Ks less than general duty pads. Andrew, what would be your take on that one?
Well, it's certainly his application's not a general purpose one. It's quite heavy. So again, it would be a heavy duty friction material that we would recommend. And heavy duty also has a higher friction coefficient than GCT. So it'll stop the vehicle in a shorter distance over a wider temperature range. So the brake torque required to decelerate a 4,500 kilogram mass is far greater than a typical commuter vehicle. So the wear rate is relative to the work done. So I'm expecting that the stopping distances that you're achieving are very similar to a typical commuter vehicle, and that's where the wear lies. Heavy-duty pads are a better choice due to the high temperature characteristics experienced when decelerating a large vehicle while maintaining a good stopping distance.
So I guess the takeaway there is that it's not all about pad life. You've got to look at obviously the effectiveness of the pad over that life. So there's that component that comes into it too, isn't there, Andrew?
There is.
Absolutely. That pretty much winds it up. We've knocked through most of those questions, and there's been a lot of informative and in-depth answers. I'm probably going to listen to this one back myself a few times to take all that in. Thank you very much, gentlemen, for taking your time out on what is a Friday today to have a chat to us, and hopefully we can do this again sometime soon.
Thanks a lot for listening. We hope you got some value out of that interview, and if you know anyone in the trade that might also get some value out of it, make sure you tell them to create a free account at Mechanic.com.au. Keep your eyes peeled for the announcement of the next Mechanic.com.au podcast to find out who we're interviewing and how you can get your questions answered. See you next time.